Hello everyone and welcome to my channel Yolo. My name is Husamuddin, or you can simply call me Sam. In this video we'll build and deploy a custom object detection model using YOLOv8, and the steps that we are going to follow. First thing that we're going to do is install our necessary tools like Anaconda. Then we're going to set up our environment using Conda and collect our dataset, which means download the images from Google and clean the dataset. Then we're gonna annotate these images using the YOLO format and set up YOLOv8 using Ultralytics Plus. And we're gonna train our model using two different ways I'm going to show you. Then we're gonna evaluate the model that we created and see how good it is, and make prediction detection on videos and images to test our model. And the last thing that we're going to do is preparing for deployment on Hugging Face by creating the logic needed to deploy it on Hugging Face space. These steps can be applied on any object detection project you can work on. Thank you for joining me on the journey, and let's get started. Before we start writing any code, we will need to set up our environment first. And we will need one tool for that. It's called Anaconda. You have to go to anaconda.com and click on this download button, and based on your operating system, it will download the correct version for you. After it's done, it will take some time. You can just go through installation. I already installed mine. It's very simple. After you are done with installation, you can go to start menu and type Anaconda and click on the navigator. It will open a couple of terminals, don't worry about it. Then it will initialize the loading screen. Then it will pop up the navigator tools right now. We will see after the navigator opened a couple of tools, but the most important one is Jupyter Notebook and Visual Studio Code, of course. After opening this and you didn't find one of this installed already and you have this launch button existing, you will find this install button instead. All you have to do is just click it and Anaconda will install it for you automatically. Then you can launch it. It's very simple and easy. And also Anaconda comes with pre-installed Python for you, so you don't have to install it or download anything for Python at all. Now after installing Conda on our PC, we can start to create our own environment. In any place that you want, you can create a new folder for the environment. Name it whatever what you want. I will call mine YOLO Safety ENV. But make sure there is no spaces between words, because this can make issues with Anaconda sometimes. And we can copy this absolute path for the folder we created and go for Anaconda prompt, open it, and write this line: Anaconda create b and the absolute path and the version that you want for Python 3.11 basically, and hit enter. And yes, give it allow to proceed. After it's done, it will tell you how to activate the environment and deactivate the environment. Don't worry about this, we will not touch this at all. We will create a new folder, we can call it anything. I will call mine the code, and inside it we will start to create our own code. But before that, we have to Conda activate the environment that we created. Right now you can see it switched from base to the environment that we want. And the cool thing, when we install any library that we want inside this environment, it will not conflict with other library in our PC already, because it's separated inside this environment only. Right now I need to install a library called Simple Image Download. The versions that I want is 0.4. Well, bam, it's installed. Right now we can start coding. Just open your editor, mine is Visual Studio Code, and create any folder file. I will call mine images because I will use this to install or download basically the images that I want. And from simple image download that we just installed, import simple image download, and we can give it a shorter name, SID for simpler name, and we will basically create SID.simple image download. We can create basically invoke it to use it to download the images. And right now, what image that we want to install? Mine, I want to install construction workers. Your can be whatever what you want, and the cool thing, you can add any amount of images that you want to install. It will be installed for you in a separated folder, and we can iterate on the keywords. In the keywords, we need to use the response that we created to download whatever keyword that you want and the amount. Basically, this will loop over our list and install each image basically in a different separated folder, and the amount that we need is 200. And with this, we can start to run it by typing Python, the name of the file that we created. After a while, it will be completed. But right now you can see there is a simple image folder. Inside it, a folder that's called construction workers. We can see one of these images already installed. Like here, it got a gear that we need, the jacket and the helmet. Well, our completed, our downloaded for the images, we have 200 images, and we can use it to annotate it. But before we proceed, I want to tell you about two places that you can get more images, like the Google Open Images dataset. It's basically for free. You don't have to pay anything. Some of it is already annotated. You can explore. You'll find a lot of stuff actually useful, but I don't think like it have it all. Not just Open Images, that's it. It's very good. Also, Keygo have a very good dataset. If we already know about these two, we can basically, I'll leave these two in the link in description, and now we can proceed to create our next step. And we have to install another library for annotation, and this one actually called label image by install label, and the I is capital image. After it's installed, we can run it. Just type in label image and it will open for us. After its installation, we can run it by typing its name, label image, and it's opened. This is basically a very simple tool actually. There is nothing so difficult about it. But before we start using it, we will need to organize our own folder structure. For the structure of the project that we will need, it's very simple. All what we need is basically to go to the code folder that we created, create new folder, call it data, and inside it we will need two new folders, images and labels. The images and labels. And actually inside these two, we will need a new folder called the train. The train is for the train dataset. Only for images, we will need another folder called validation, or call it just val. And here in labels, we will need just train. You will understand why we're doing this in a minute, but be patient with me. Then we can take from our simple images construction worker. Like you can see, there is some images that's not clean. Basically, like this is not construction worker image. You have to clean these images and select like 100 of it or 50 images, however much that you can basically want, but I would recommend it's like not less than 40 images basically. And clean the data, take your time and clean it, then copy what you need inside the train images folder that we just created. Right now I selected the image that I want to clean, basically want to work on, and I will take it to the data images train folder and post it right here. Bam, and we have our images. Right now our image is ready to be annotated. All what we need to basically to go to our terminal, write label image again, and it will open for us, and select the directory of the images. Mine is already, I have been selected before, so I just can select the folder and the output where we want it to go. In our case, we want it inside the data labels folder that we created inside the train folder, and we just select where it want to go. And before start, please make sure that you are selecting YOLO, not any other format. I made this mistake before. After I am done with like 50 images, I realized it's not YOLO. Anyway, right now I will show you how to create the annotation. It's very simple. You click this rectangle box, go in where what you want to label, basically the bar that you want to object detect. Here we create this box and we will label it, call it head. It's very simple. And we want to also the jacket to be detected, so we create a new label, call it jacket. Okay, right now we will have to do to all this basically hat and jackets, and after we are done with any images, basically all I have to do is click save and continue to the next one. I am done with annotating the images finally. Inside data images train, you will find the images that we wanted to annotate basically, and for each image name here, building worker 3, basically inside labels train, you will find the same name but for a file called txt. This is basically the where is the labels that we wanted on the images basically. For 0 is hat and 1 is a jacket. This is basically where is this object exactly for inside the images. This is YOLO how to understand where is the object in images. And from here, we want just the classes text. We will put it outside here in code. No, I will put it in data. And for the classes, we have just hat and jacket. That's what we created as labels. Alright, right now we're gonna start coding and installing what we need to train our own model. The first thing that I need to talk to you about is this library. It's called Ultralytics Plus. It's basically YOLO but for deployment on Hugging Face. And I feel like that if you created a model and you wanted to share it, the best place that you can put it on right now is Hugging Face. It's a very famous platform for uploading, and we're going to use Ultralytics Plus to do that. And all we have to do, if you remember, we just have to go to our own account abroad and install, basically Bible install Ultralytics Plus and let it do its work. Right now, after it's installed completely on our environment, we need to check on Torch. write Python in the Anaconda prompt. It will open a coding place, then torch and torch dot underscore version underscore. Right now, as you see, it's CPU. The CPU, we can use actually the CPU version, but it is very slow and it will take a lot of time. What we need to install actually is the what do you call it, the GPU version. We can go to pytorch.com and click on get started. It will give you the selected option here. You can, of course, you want to select it stable version and the operating system that you have, Mac, Linux, and Windows. And we need to install it with pipe, and the language is of course Python, and the Coda is the newest one. It give you this command prompt. After install, we will add a -- upgrade, and it will continue Torch Vision, Torch Studio. I will leave this command in the description. It will look like this. It will take some time to install, and after installing it, will replace the CPU version automatically. You don't have to worry about it. Right now we completely installed our GPU version on our environment, right? Okay, right now again we will check on it the same way we did the last time on board torch dot underscore version underscore. And here, if you can see it correctly here, right now it's with Coda. Basically, there is no CPU version existing on our environment, and that's what we want. Because that means the CPU a Torch version is extremely slow. You don't want to use it. Now we can start to creating the code that we will need for our basically model. The very next thing we need is YAML file. We can create in the coding folder to create a data config YAML file, and here we will give it a few things. I will explain it. The first one is path. Where are our root directory for the dataset? Okay, and where is the train? Basically images. It's inside images the train, and for validation it's inside images val. Okay, how many classes do we have? In our case we only have two, the hat and the jacket. And what are the names of these classes? The first one, if you remember in the class text that we saved here, first one is hat, second one is the jacket. We will make it in the same order. You have to remember that, because if you reverse the order, the training will be flipped. And right now we almost ready. All what we need is just where are the base root. The base root is basically the data folder that we created, and give it the absolute path, and we copy it and put it here. Right now our YAML file is ready. Right now we can start to create our own model code. Finally, we can do it in two ways. The first one is Python code. We create a file called modeltrain.py. Inside it we're gonna import Yolo from Ultralytics. And we're gonna select which model that we want. For sake of this tutorial, we're gonna stick with a simple version model. We will have is v8n.yaml. I will leave the link for the other model. Basically the n8n, basically the smallest one. There is S and M and L and X. There is basically the larger the model is, the more accurate and it will be, but it will take more time to train it basically. And for right now we need to basically talk about the results. we're gonna use this model that we selected to train, and we're gonna give it a couple of stuff. First thing is data, and what is the data? Is basically the config file that we created. .yaml. And the next thing is epochs, is the amount of time that we want our model to look to the images. 100. It will take more time the more you add. Like basically the 10 is less than 100, so it will faster in terms of train, but it will be less accurate. The image size, basically the standard size, and the workers is 1, and last thing is batch. I'm gonna set it for 3. Batch is the collection. Basically think of it a bunch of images in one image, and the model look at it. We can put 3 or 4 or 8, but the more that you put, the more consume RAM that you will need. And this is how you create it in basically Python. You can run it, and basically it will start to train your model. But there is similar other way we can use. We can, in any terminal inside our environment, we write YOLO task detect, but the mode is train, and the amount of epochs that we have is 100, and the data, it's the same file, data config .yaml, and the model that we want to use, we will use the YOLOv8 dot. Instead of YAML, we'll use something called BT, and image size is the same, workers is 1, and batch is 3. With just one line, we can train our model. I'm gonna press enter and it will start to train. We started downloading the model that we selected. It's a very small model, actually, it's just 6 megabytes. Right now it started to train. This will take some time based on your GPU, and after it's done, I will come back and we're gonna see the result of the training itself. Okay, the training has been done. Right now it looked to 50 images, and it took a little time mostly because it's 100 epoch. Right now we can go to the code folder that we created. We will find a new folder called runs inside the detect, and the only training that we did. First thing that we want to look at is the result PNG. If our training loss is not going down like this, you did something wrong. It might be the image is not enough, the amount of epoch is too low, or something like that. You have to make sure that the loss for the training box is going down and the precision metrics is going up. Because this also, if going down, that means there is something wrong. Precision means it's able to detect the objects inside our images. The validation, I didn't do validation. We will leave in the GitHub basically what I did for validation, but it takes its own validation. Anyway, you have to check that the loss is going down and precision going up to make sure that basically the training is good. Where our model, it's inside the weights. There is 2 models. One is called last and the other one called best. The best one, that's what we will use. The last one we usually don't use. We can take a look at some of the images and see that it's detected. 0 is a hat, 1 is a jacket, right and right. Nailed it. Like this is what we want exactly, and this is perfect for us. Before we start thinking to put our model on Hugging Face or any place, we have to test it first. We can do this by 2 ways. The first thing is using code, Python, and of course a command that already made by Yolo. First thing we're gonna do is the code, because it's the easiest one, believe it or not. predict from ultra import YOLO, and the model, this time we're gonna use our model that we created. Remember, where did you bought it, or the result of it is basically inside runs detect rain and wait, and we're gonna use the best version. And the second thing that we need to talk about when we creating this code, and we going to use the model to predict a video. First thing, I have a couple of videos here. I'm gonna leave it in the description where you can get it, and we want to save the result, of course, by save, and we need to also show it. That's optional, actually, you don't need to show. And confidence level, we're gonna do 70% confidence level, basically how much the model is sure about what he's seeing. And that's it. Save and run. Take some time. Okay, it's done predicting, and right now we can see where our results. It's our side run detect predict, and we're gonna see this video. So already working as intended. It can detect jacket and hat. That is perfect. That's what we need to know. But sometimes it get like not sure if it is a jacket or not. I understand why, and I'm going to also mention how we gonna improve this work by making the model see more images, basically, and using the better version of the model of YOLO, basically the L or the M or even the X, and turn it or more time, like for instead of 100 ebook, like it took 100 or something. That will make it better. Alright, right now we're gonna try to predict an image and see if it can see the jackets and the hat by using an image from the validation. But there is one option for the images. Actually, we can save the bounding box of it in just one option, save txt, and set it to true, save and run. Let's see the results. Side predict 3, and you can see here predicted here, this is the hat, and this detected this jacket and the hat, and the labels that detected the one is the jacket. It just saw one jacket in the image and two hats. That's perfectly working as you intended. Okay, let's try the same thing but with command. This command is very simple. Don't worry about how long it is. It just basically YOLO a task detect, the mode is predict the model, where is base of the model that we created, basically show is true, the confidence level is 17, you can change it, and the source, basically where's the base of the thing that you want to detect, an image or a video, save is true. Where this is project basically mean where do you want to output be saved. Let's hit run and see the results. Okay, doing the same thing exactly. So there is two ways that you can run detection on a video or an image as much as you want. You can use code or a command. Alright, right now we're going to work on the Hugging Space part. Hugging Space is a platform that's free to use. It's over a lot of stuff like datasets and pre-built model. It is very famous. If you don't have an account, you're gonna need one to create a space inside it. So I will leave the link in description for Hugging Space so you can create an account. Right now we're going to install few libraries that we need to continue working on the Hugging Space preparation to upload our model. We're gonna use pip request basically to build our requirement.txt and Gridio. It's an interface for machine learning model. and we're gonna install it in our environment. Remember that? Alright, right now everything I needed installed, and we can go to Hugging Space. After you're done with the creation of the account, I want you to create space. You can come to this page and click on new and click space and select the name what you want. Mine, I will call it YOLOv8 safety, and the creative licenses we're gonna collect CC, and for this we will select Gradio. Gradio is what we're going to use. It's interface that we are going to use to create our app, basically for Hugging Space. Create a space and it tells us what to do. First thing that we need is to clone the space that we created. Let's go to our code. Let's open our editor and ask it to basically clone this folder. Right now it's cloned. Let's jump inside it. YOLO safety, where it is. Yes, it is. Alright, we can inside it to create a new file. We're gonna call it app.py, and inside app.py we're gonna create a couple of stuff that will run our code as we wanted in Hugging Space. The first thing that we going to do is import libraries that we will use. We need Gradio and Torch and Ultralytics Plus, not just Ultralytics, the Plus, because it will render the results and show it to our basically users. Second thing, we're going to download a couple of images for our model. Basically, if you're detecting whatever, you get an images, a links, and put it here and give it a name. And Torch will handle the downloading of these images from the web. And right now we're gonna talk about the most important part, is the detection function. This function, you can call it whatever what you want, it doesn't matter, but you have to pass it this couple of parameters. The first thing is the image that you want to detect and the image size. This is important because the smaller the image, the harder it's for the model to detect the objects. And the confidence, you already know what is the confidence threshold, I explained before. And this IOU is basically the grids of YOLO that can detect our objects. The base of the model will be in basically the folder that we created. What the name of it is the best, we're going to use the best BT that we already created. And the results of this model will be the prediction from the model, and we pass it the parameter that we already give it to the function. Right now we're going to use something called the boxes. What it say is the boxes around the object, and you will see this when we upload it. And we're gonna render the result of prediction that we have from the model and the image, and the results is basically the first thing in the array, and return it. This is the hardest part actually about this app. The coming stuff is very simple. Next thing is the inputs. What basically grid you need is an inputs, output, and of course the function and title and example. We give it the function, we give it now the inputs. It's basically the sliders for our, or basically inputs for our function, like where you can put the image and select the size and the confidence level, and all other inputs basically is the slider and they created here. Output, where we're gonna show the image, it's basically the base of it, and the output image it's going to be named. A title of our project, I'm gonna call mine YOLO8 custom object detection, and some examples. The example is basically we giving the function up here one of the images that we downloaded and the parameter. Okay, it's very simple. And last thing that we're gonna create is the Gradio interface. We passed the function that we created, the inputs that we made, and where we want the output go. and the title of our projects, and of course an example. And the last thing, that do we want to cache the example that we created? You definitely won't do that, so you don't have to basically take time to predict a model every time. You definitely want to cache the example so the detection will be fast for it. So right now we're going to create a requirement text. Requirement text is what we basically telling the space what to download from the internet to make our code work. Just this line. I will leave all the stuff in the description so you can basically copy and paste. This page request we already installed. The requirement text is over here already created. Yes, the Gradio version that we installed, the Ultralytics installed, and you can just remove this version. You can let it loose. Basically, Hugging Face will handle which version we use of PyTorch. And the last thing that we will need is, of course, the module that we created. It's inside train, weights, and copy. Go back and put it in here. Right now our model and file are ready, and let's see what it tells us. Of course, git add. Instead of app.py, we will basically add everything and commit our basically file. I'm gonna git add. If you don't have git, you have to install it, and we can copy the rest, git commit, and finally git push. Right, my space has completed. Right now that we'll see the cache is done and building is done. Okay, as you can see, this is how it looked. This is the input that we created. This is the output. Images is our example. Let's select one, for example this one, and it's already detecting correctly. This is a jacket. This is a hat, but it doesn't detect this is a jacket. But I can see this is a jacket. Maybe if I make this image a little bigger, submit. It will take time because this is for free. Yeah, it doesn't detect it. Actually, you can play with slider so you can get a better result. Maybe with this image, for example. All the stuff will be on GitHub, so you don't have to worry about the resources. Okay, you can play with the sliders, make this confidence level a little bit low, the iOS threshold a little bit high, and see the results. But that's it. That's basically how you can create a model and detect your own database. We learn how to collect data set and annotate, and how to train our model in different way and use it and see the details by yourself of the results, and how to create a Hugging Space and upload our model on it and make it work. Hopefully you learned something from the stuff. All the code and all the resources, you will find it in GitHub. I will leave it in link in description. Thank you for watching.